Hey everyone, thanks for tuning in today. This is the latest in our webinar series where we have the pleasure today of welcoming our very own Daniel Pope. It looks like we're in different rooms. Actually, we're all seated next to each other. Matteo is here with us too. It is a pretty nasty Tuesday evening here in Barcelona where the weather has not been doing us much favors, but this time it is nice to be doing it from Barcelona, which is super. Our topic today is has to do with the economics of immersion cooling for HPC. And what we're talking about today is very relevant because of the upcoming Supercomputing 19, which is happening in Denver. And I think we're going to see a lot of you there. We're very excited to be attending. We'll also have another Smart Pod, which will be hosted by one of our very good hardware partners, guys called 2CSI. We will also be featuring some hardware from Fujitsu, from HPE, from some other top manufacturers and top HPE manufacturers, so make sure that you come by. I think most of you know me at this stage in this series. We've been doing this since February of this year, always to do with something to do with HPC. Anyway, Diarmuid is how you pronounce my name. Most people call me D, so there you go. Please call me D next time and don't butcher my name. That's fine. Okay. If you are not aware, we're kind of present on quite a lot of channels here at Submer. We've got a little bit of YouTube content, stuff that we constantly build up. You'll also see our very own Matteo, who's very active on some of the other channels like Instagram and Facebook and on LinkedIn. Also, this particular podcast, along with our others, will be made available after this. Slightly edited format, nothing serious, top and tailed, and then it'll be published to various podcast channels. And apart from that, I just want to say that you're welcome to ask questions at any stage here. Of course, we prefer if we're interactive here. It's not meant to be a broadcast to you. It's supposed to be definitely getting to the questions that you want answered. So before we talk about Daniel, I guess we just talk about Daniel. That's the way to do it, really. What else can we talk about? He's even wearing the same shirt in this picture as that one. How did that happen?
Just took it now.
Okay. I don't think Daniel needs any particular introduction here. I think most of you are very familiar with us, with Submer and with Daniel. Again, there will be a great chance to speak with Daniel both at DCD London, which is coming up on the 5th and 6th of November, and also at Supercomputing 19, when he'll also be with us in Denver. So Daniel, welcome.
Thank you. Thank you.
This is cool. No, it's really cool. And, you know, we're just going to take this one step at a time, and we're going to be looking into the economics from different perspectives. Of course, there will be an emphasis on immersion cooling today. But again, keep those questions coming, please, if you have anything else to add from a HPC note. Let's get started straight in here. Daniel, what is this?
This is a supercomputer. But this one probably dates from the 70s, I would.
The 60s, I think.
Yeah,
even, yeah.
That far back.
Yeah.
So yeah, this is what they used to look like. Usually just one big, massive machine. Some of those first ones were actually liquid cooled, but most of them were air cooled. So pretty much like we do now. This is actually the Cray 2, the first supercomputer that was liquid cooled. Also using, of course, a dielectric liquid with the components fully submerged in the liquid. So it seems that we're coming back to this.
Okay.
And today, so here we have an image of Summit. Summit is today the #1 on the top 500 list. A combination of direct-to-the-chip cooling with RID or heat exchanger with traditional air cooling and air handling units. So a pretty big mix of technologies there to achieve the densities that were required by Summit.
Okay. I would ask people if there's, just regarding some of the questions as well, if someone can also give us some insights as to, apart from the financials, but why national labs have always been so strong in supercomputing and HPC, etc., would be great to know from you guys. I see there's already a question in, we'll come to that in a moment. This is part of the next generation. I believe there are 3, I think, that are coming to the national labs.
Yeah, we have a Capitan, we have Frontier,
Aurora or something like that.
Yeah, Aurora, exactly. These are the 3 already in the exascale size that will be deployed. The earliest that we'll see, I think, is 2021 for Frontier. And that's an AMD-based supercomputer, which is interesting to see a new player going directly into that scale.
I think it has something to do with their new EPIC, with the new Rome CPUs as well.
Yeah.
And I know they'll be using their own brand of accelerators or their own brand of GPUs. I'm trying to remember their name, not coming to me right now off the top of my head. However, it's you know, it's good to have competition. We at Submer, we also welcome competition. We think it's healthy, and a little bit like there's a Boeing and Airbus. In here we have like Intel and we have AMD, but of course there's also IBM as a player, which is probably part of some of what that we're going to look into in a little bit more detail.
Yep. So just briefly going through the benefits of why we see immersion cooling more and more in the HPC space. HPC really being the Formula One of compute. There's some obvious pains that need to be challenged with HPC and in the HPC space, and obviously one of the main ones is trying to get that electricity bill reduced as much as possible and getting as much compute as possible out of that operational cost. So energy reduction is key. We're seeing a clear direction in the increase of rack density for the new supercomputers. So we'll see now the numbers for Summit, but some of the projects that we're involved with already in the 80 kilowatts per rack, which really is pushing it for air. Actually, forget about air, it's just a part of the solution for these densities. And obviously, nobody who's deploying those densities for HPC is even considering air-only approach. So you definitely see liquid being implemented. Of course, quicker and cheaper deployments are then just, let's say, a secondary benefit to the technology, but maybe not so critical in national labs, but obviously for corporate HPC deployments, building for less is key.
Okay. I know we'll be coming as well to a particular use case a little bit later on, where I know you shared it with some of the people who were fortunate enough to attend the OCP Summit.
Yeah.
But we're going to cover it again because this is mostly a different crowd. But here we have an AC922 from IBM, which is actually the node used in Summit. Maybe you can tell us what is it about this which you think is possible to optimize?
So this is a pretty standard node in the HPC space. It's in multiple supercomputers across the globe. There's air-cooled version and there's liquid-cooled versions. The liquid-cooled versions allow you to push more cores into the CPUs. So these are Power9 CPUs. There's 2 on each of these nodes, which have a pretty high power consumption. I think around the 400 watts, if I'm not mistaken,
correct,
per CPU. And then we have 6 NVIDIA Volta GPUs. So what's quite obvious is that this is an image of a liquid-cooled node, and that's exactly what's deployed at Summit. So these nodes have a set of pipework and cold plate heat sinks that are used to remove the heat from the systems. And obviously, I think one of the challenges here is that, as you can imagine, the complexity of all this pipe work and the additional cost of these, let's say, specially designed heat sinks and cold plates are something to be considered and that we'll be digging into during this webinar. But just briefly on the number there to the right, so Summit is approximately around 14 megawatts in its whole, so cooling plus compute, and 10 megawatts of that is the pure compute, let's say.
Okay. And if we look here maybe at models that we have been using of late, maybe you can talk to us about this. This seems to me like an 8 GPU node, is that correct?
Yeah, so this is one of the Atlantis nodes that we've been deploying in some of our supercomputers from one of our partners. There's 8 GPUs in these nodes instead of 6. There's also 2 CPUs. The power draw of this system versus the one that we were looking at is very similar, and thus the compute capacity is also pretty in the same range. Now, the main difference is there's no piping, the chassis is much simpler, there's no components which are used to support air handling or air cooling in the node. So essentially what you see is a much cleaner environment or footprint, let's say. And then that leads to no moving parts. So by immersion cooling, by using immersion cooling to cool these nodes, we reduce drastically the amount of cooling capacity required versus IT, whereas you can see here that for these 10 megawatts, we only really need 30 kilowatts of cooling capacity.
And also with no moving parts, far less hardware failures as well.
Absolutely, yeah.
Again, looking at Summit in particular compared to one of our recent deployments here, we're talking about different rack densities.
Yeah, so one of the questions I think that we get the most with immersion cooling, where the first thing that comes to mind is, okay, this is horizontal, so it's using up more space, so it's less dense. We like to challenge that very quickly because it's a common discussion. So in just as an example, Summit has a rack density of between 55 and 59 kilowatts per rack. The compute racks are much denser than obviously the storage or the networking racks, but that's on the higher end of the configuration for Summit. And that really, there's a combination of, as we said, of cooling technologies that go into that mix to achieve that. Obviously, it's not just air. So there is liquid cooling, there is a water loop that's taking away the heat from this system. And that water loop is chilled some parts of the year, and it's just economized water for most of the year as well, because it can be achieved with dry coolers part of the year. But if we were to take the same temperature at which Summit is run, so the same water loop temperature at which Summit is run, and we apply that to our technology, so specifically we plug that same water loop into the smart pods, we can achieve more than 200 kilowatts per smart pod.
I think it's also fair to say, though, that of course we're trying not to use any chillers. We're trying to use the most efficient solution possible, and therefore our nominal value for a smart pod of this size here is 100 kilowatts of heat dissipation using only ambient air temperature. We've had a couple of questions in the meantime, Daniel. I want to just stop into it right now as well. So we have Kuhn Rad asking if we have a list of data centers that are ready for immersion cooling, and do we actively work together with data center providers to become immersion cooling ready? And The answer is, of course, yes. So today we are working together with companies like Vantage Data Centers, with Evocative Data Centers, with Digital Realty, with a number of other co-location facilities who are indeed ready for immersion cooling. They have water piped right to the data center floor. They are very much friends of this. Of course, in each case, they are dependent on their particular tenants, so on their customers and partners. But there are others as well who are looking at this, people like EdgeConneX and a couple of others, HK Colo in Hong Kong, just to name a few. And of course, there are some very, very wonderful European people like Eco Data Centers that we will hopefully look forward to working with in the future. And I think it's fair to say that a lot of the major players are definitely looking at this because in some cases, Code Telecom as well, sorry, I can't forget Code, you're right. Yeah, so they are doing this for one particular reason, because their customers need it. And we know of several cases in more recent years, in the last 2 years, where two of the ones I named, I won't specify which ones, were passed up for particular projects because they did not have that. And also their customers never even asked them. They went ahead and did it themselves. So it means it's really changed how people are thinking of it, and they are piping that directly to the data center floor.
Yeah.
Okay. All right. Well, going back to what we were doing, and just maybe again talking about this wonderful node here. It looks beautiful with all this copper, Daniel, no?
Yes, and even more in this image where the copper actually even looks like gold, and then it gives you a sense of how expensive these nodes are, probably. But so yeah, there's a mix of cooling technologies that go into achieving that range of density in a rack, right? So we have on one end the what can be seen here, which is the direct liquid cooling, direct to the chip cooling, with the pipe work that represents. So actually in this node, there's probably about 20 different liquid connections, pipe connections. And in the whole of Summit, there's more than 100,000 pipe connections. So something to consider, each of those connections being, of course, a risk there. But going back to the technologies that are involved, so we have direct to the chip cooling. We have rear door heat exchanger. So the heat that is released out at the back of the rack is captured by a rear door heat exchanger, which is also liquid cooled. So two different types of liquid cooling technologies. And then the third cooling is the traditional cooling that we're all familiar with, and it's the crack units with air handling units deployed across the data hall for the rest of the heat. So direct to the chip liquid cooling is usually not capable of taking away more than 70% of the heat of a system. So as you can see, for example, the power supplies are not cooled with liquid, and there's many other components that are not cooled by liquid. And that heat needs to be accounted for with the rear door heat exchangers and air handling units.
I would ask people also to please consider that we are also talking about the fact that there are fans here, because the air still has to be driven here in this case from the front to the rear, and then in order to be brought over the rear door heat exchange. And we know that there are fans both in the racks at Summit and also in the nodes themselves.
Yep.
Okay, maybe the other side of things.
Yeah, so here we have an image of a typical installation, HPC installation, this one specifically with Open Compute hardware. But essentially very similar nodes. Actually, it's the identical node that we were showing before in the render. So 8 GPU nodes with 2 CPUs, fully submerged in one of our SmartPod X units. This is the larger version, the XL, which can host up to 42 open use, and 45 use of 19-inch hardware, and dissipate up to 100 kW with warm water loops, ambient air, and we'll go a little bit more into detail in a while regarding that.
And here, when we look at the hardware costs, I think some of this, of course, is a matter of how much was purchased at the time. Was it purchased at the peak? But for instance, each node used in Summit would have been very early or would have been top of the range at the time. So it is not surprising to hear that these water-cooled prepared nodes would be in the region of about 195K each. And there are quite some of these. And we know the whole project was $600 million around, sorry, it was 200 million, sorry, 600 million is the new El Capitan. And then these nodes, I mean, not only these nodes, but if you take the same node or the same design prepared for immersion cooling, how do you get such an advantage? Why is it 30% cheaper?
So this is a conclusion that we've already reached to with quite a few OEMs. When you take a node that was designed for immersion cooling and you put it into, that was designed for air, and you put it into immersion cooling, the first thing that you realize is that you can remove a lot of components that you originally put in there. That includes replacing more high-grade, high-end heat sinks for cheaper heat sinks. Obviously, we would completely remove any type of direct to the liquid cooling components, which are deployed in these specific IBM nodes. And a lot of the air handling components that exist inside the server are also removed. So as I was saying, the conclusion that we typically reach to with an OEM is, let's just design a much simpler server design that removes and provides us all this new footprint that we can use for additional compute. So get more GPUs in there, essentially, yeah.
And also, this is something that we have started working with some of the hardware manufacturers with. We're in early talks with some of the IBMs and some others as well about designing things specifically for immersion cooling, where people can place those components closer together or pack more GPUs into the same space or whatever. It may not be GPUs, it may be FPGAs, who knows what's coming down the line.
Well, so immersion opens up a whole new set of opportunities for not just the server manufacturers, but even the power supply manufacturers, where components need to be spaced at a specific distance based on ASHA standards, and with liquid environments, those components can be placed way together. Submerging batteries and things like that as well is another opportunity. So UPSs submerged in immersion could deliver substantial benefits as well, and also ease the facility side, the design of the facility. So all these things are topics that we're discussing with OEMs.
Yeah, and as we've probably covered a few times, we are considering the traditional white space in basically trying to help people to understand that, yes, I understand if you spend 600 million on a supercomputer, you want it to look beautiful and it has to have the right logos on it. But apart from that, really economics, and when we're talking about the money should be going into the ability of the compute nodes and not necessarily the beautification of the building. So I think we're just here again talking about the economics of the building. So we don't need those white spaces or traditional white spaces as well for supercomputing. And again, what is the difference in the footprint, and why is this so massive?
Yeah, so here's a comparison between a supercomputer for the same capacity in immersion cooling versus the combined technologies that we see in Summit, for example. And it all comes down to that rack density that we were looking at. And that rack density isn't considering that we're still far from it, but it's possible to achieve a much higher compute density in the same space. So this is just challenging that difference in rack density versus the traditional approach. So, for example, in the case of Summit, it uses a footprint of 860 square meters, just under 10,000 square feet. We could deploy the same amount of compute, those 10 megawatts of IT compute, in just under 300 square meters or 3,200 square foot.
Okay. And you had some good comments when we were looking into this earlier on today. The fact that, yes, they're trying to do the right thing, absolutely, with the on the cooling side here, because they are using ambient air when it's possible.
Yeah, so there's economized air cooling, water cooling during most of the year, and that's really what allows Summit to have a pretty competitive PUE. The problem probably is that they still need to run those water loops at a pretty low temperature. So I think the water inlet for specifically Summit, it's indicated here, it's around 70 Fahrenheit. And there's a combination of obviously shaving the peaks with chilled water, as can be shown here. All these diagrams are public information from the Oak Ridge labs and so on. So, yeah.
But you're saying that we would use only let's say the passive cooling as such, rather than having any compressors or chillers.
Absolutely. So we would take an approach, a much simpler approach with less infrastructure, which essentially also means less space on the outside and the inside of the data center, because that's also something to be considered. But the water temperatures that we would typically operate our systems at range between 113 Fahrenheit and 122 Fahrenheit, which we can also raise, and this really depends on the type of hardware being deployed as well, and on the region. But it really does mean that we can use dry coolers practically anywhere on the globe, and there's a substantial saving in that part of the infrastructure and the maintenance of that infrastructure, because it's just much simpler to deploy and maintain.
Yeah, I was speaking with an energy company in the Nordics earlier on today, and we're working on a project together for heat reuse. Something which is very popular in Northern Europe and which is going to become increasingly popular, I believe, also in North America. There are even some provisions in Loudoun County, even for some district heating, etc. So supercomputing is, of course, one of the consistent generators of heat, which is one of the things that they need. They need to know that they're going to have that heat. Of course, there's some kind of backup to it as well. However, being able to reuse that and having a system by which to reuse it really gets PUE in a crazy place altogether. And again, when we sit down and work out what the cooling costs per year of Summit are averaged, and we would be glad to get some very specific data from our friends at Oak Ridge. Please, if you have some good input for us, what we can calculate from the outside looking in is approximately $3.5 million per year if you are paying in the region of about 10 cents per kilowatt hour. Now, being from the Department of Energy, I presume there's a deal in place there, but anybody has any insights who can also type that into the Q&A, that'd be fantastic. And is this a joke?
Well, this is essentially the difference between a PUE of around 1.5 and a PUE of 1.03, which is what we'll typically see in a full installation, obviously accounting for the dry coolers and the pumping systems.
Yeah, I think Matteo put together this graph, but I think we already got that the difference is huge.
Yeah, I mean, this is obviously very visual regarding the costs, the operating costs for energy on the cooling.
Indeed.
So resuming, there's that challenge, that main difference there with the PUE between one system and another. Now, we've done a little bit of a trick here with the PUE, because the reported PUE of Summit is
between 1.15 and 1.2.
Yeah, exactly. But of course, we need to account for the fans that are in those systems and that obviously immersion environments don't have. So this is what we're typically seeing in air-cooled supercomputers as a kind of medium PUE. The triple cooling approach, so air handling, rear door heat exchangers, and cold plate direct to the chip cooling. Obviously very noisy environments, that's probably a secondary pain, let's say, but in immersion cooling, that's something that does not exist. I think I posted a video some time ago where we were showing that one of our data halls with smart pods was generating 37 decibels of noise, which is the equivalent to a library, so very quiet. We've seen the reduction in space, the density that immersion cooling can bring to the HPC space, and obviously the reduction in the cooling costs.
Okay, and just very briefly here before we come into the questions, just Daniel, if you could help us to understand this particular deployment that you've shown us one of the nodes from, or one of the smart pods from, please.
Yeah, so we did announce recently, and a lot of information is still embargoed, but because it is a
public body.
It's a public body and it's in the security space, so not all the information of the contract can be exposed, of course. But we recently partnered with Airbus, so a well-known public listed multinational company, and built a supercomputer for the European Commission, which is managed by the Joint Research Center, an R&D arm of the European Commission. This supercomputer is in the megawatts range as well. So a number of our units being deployed and a few hundreds of nodes being deployed. It is a interesting partnership between this public listed company and a few of the ODMs, original design manufacturers, and some of these names might be more or less familiar, but the hardware that was chosen for this specific HPC deployment was open compute hardware, which actually brought in an additional saving. Very interesting, because there was nearly a 10% saving versus traditional 19-inch hardware. And this is one of the pilots, the first units that were deployed to test and integrate and evaluate all the hardware that was being used for this project. But a very exciting project. Being a European-backed company, it's exciting to see how our own technology is actually being used by the European Commission now.
It is nice, and of course it was great collaboration between, here it was 2 CSI, we have Gigabyte involved too on the motherboard front. Light-On providing those power shelves that you can see about halfway up the picture, and then just at the top as well. And NVIDIA, of course, providing the GPUs. Okay. Oh, that was a lovely picture of Daniel and Joanne. Joanne is our operations manager here, actually at CERN, at the Large Hadron Collider.
Yep. So here we're exactly in the LHCb experiment at CERN, the Large Hadron Collider, who obviously have a very interesting challenge regarding HPC because of the sheer amounts of data that they work with and the complexity of the architecture of the accelerator itself. We're working very closely with CERN and hoping to solve a lot of their challenges through immersion cooling.
Okay. And then another interesting deployment, a project that we're working on together with the Barcelona Supercomputing Center, and hoping to be a part of that future also as they go towards exascale.
Absolutely, yes.
So jumping into some of the questions that we have here, Daniel. So we've already had a quick look at that. So there was also a question from John. My view as chair of an HPC user group for 20 years in a large university, I would say being shared systems together with addressing computer data applications that require large systems, the larger the better. And such centers are able to pool funds and resources to provide these systems for the HPC community. Maybe, John, you can help me with the question there. It's nice to hear, and it's great to hear from you. Thank you. Kunrad, you've also talked about again, yes, we have an ROI calculator available, and I know that we'll get your details and we'll note to make sure to share that ROI calculator with you, absolutely. Okay, John, maybe we can come to your question here now. Yes, indeed. So with OCP, many systems obtain power from a DC bus bar, for example, with the Open Rack project. How is this dealt with in the Submer setup?
So Submer released the first OCP compatible immersion tank, the SmartPod. Our SmartPod X is compatible with standard 19-inch and OCP Open Compute hardware. Essentially, we've adapted the Open Compute rack, which is primarily led by Facebook, into the SmartPod. And so we've developed a system to protect the bus bars at the bottom of the tank, and essentially the exact same hardware that can be used in OCP racks and OCP spec can be applied into immersion cooling.
So those servers click into the bus bar?
Those servers click into the bus bar, the power shelves click into the bus bar. We have worked with some of the manufacturers to avoid some of the challenges, like the specification was defining that it wasn't defining that the power shelves had to be bolted onto the bus bar, but as a defect, everybody was bolting the power shelves to the bus bar, which obviously for immersion, it wasn't in our interest, and the bus bar manufacturers very gladly supported us in developing clips instead of bolts to the bus bar.
Really cool. And what arguments would you use on people who are skeptical towards immersion cooling, so to convert them? I know this is something we come up against every day.
Get your hands wet, try it. I mean, really, it's more of a mental leap than anything else. Once you see it in action and use it and see that it's just as practical than traditional air systems to manage on a day-to-day basis, but the massive amount of savings and density that you can achieve, it's a no-brainer, and it's a really fast process. That's what we see. So the pilot installations that we deploy, they convert so quickly to follow-on orders, and it's mostly because it just takes a little bit to understand and get familiar with the technology. And once you've overcome that, the switch, then it's easy to embrace.
And again, I think it's a good point to invite everyone who's here, and also anyone you're speaking with, if anyone has anything regarding, any questions regarding immersion cooling, I think it's worth seeing in person. So not only at shows like DCD London, or now upcoming at the Fujitsu Forum, or at Supercomputing 19, or also we're doing an open day, I know we'll be mentioning it one more time, together with evocative data centers in San Jose on the 14th of November. But we have a permanent demo set up as well at that evocative data center in San Jose. Also, we will have another one back up and running again at Digital Realty in Ashburn, Northern Virginia. We also have some in the south of England, soon coming to Hong Kong, Singapore, some other locations. Of course, everyone is always welcome here at
London, no? Hopefully,
yeah,
as well.
Absolutely. also in London together with Colt. But if we also think about Barcelona here, where people are welcome to spend time with us here, understanding all of that, all of these sites are there, and there will be a lot more as well. So we hope to be deploying soon in Texas, in Phoenix, in Dubai, in Chicago, Dubai and Abu Dhabi also upcoming towards the end of November this year. And there's no substitute for being there in person and for getting your hands wet. You won't get them wet, but you'll get some coolant on them, and we will gladly clean it off. Okay, great. Let me see. So we have another question here regarding, so OCP typically have identified large heat sinks and larger fans in many applications, but do you think smaller heights are better for immersion?
Absolutely, yes. So that's something that we've tested already with quite a few OEMs. Remove these expensive, sometimes even two-phase type of heat sinks that are designed to move heat to the rear of the server and that have a substantial cost for some very basic €10 heat sinks that you can buy off anywhere, and achieve exactly the same performance. So massive amount of saving on that specific component of the server design.
And also the space, which is made available.
Absolutely.
Great. A question from Kevin. We're working with a US government facility which is currently using rear door chilled water cooling at about 36 kilowatts per rack. Have you completed any US government work with similar equipment? So we're obviously, doing this with immersion cooling, and I can report that we are dealing with some of the national labs. We're in very early stages. We hope to be doing some work with them sometime soon. As everybody knows, working with public bodies and stuff like that, these things take time. So I don't expect us to have anything big to announce there before sometime like around about the middle of next year. However, it is just like by orders of magnitude more efficient.
Yeah, absolutely. And I would like to add to that, we are present in the US. We have an entity in the US, Submer Inc., and we have people on the ground in the US, so please reach out to us and we're happy to support you there.
Great. Super.
Oh, by the way, also manufacturing in the US.
Oh yeah, that's right. Actually, just a little anecdote. I had the pleasure, together with Jeff, our managing director in North America, we went and visited the plants in the US, which are manufacturing our first units. And it was absolutely amazing to see how our technology is now being produced across the pond, and really, really great. We're just looking forward to great things to come. Okay, and John, I see that your first entry was in response to the question at the beginning, the presentation of hosting of HP systems, so HPC systems. So I think you're just saying that it makes sense to have many together in that regard, I presume. Again, maybe, John, we need a conversation after this.
HPC co-op.
That sounds good. That sounds good. We have another question regarding how do we solve the issue with the coolant creeping up RJ45 cables? Similarly, how do we solve issues with fiber cables that do not like the coolant? Two interesting questions.
Yeah, we're tackling that from two different aspects. As you know, it really doesn't matter what fluid you use. Capillarity exists. That's something that's intrinsic to using liquid. There's some ways to overcome it. We're working with some. First thing is less cables the better, obviously. That approach and open compute helps a lot there. And we're working with the open compute community to even go further, a few steps further in that direction. We are working on the fluid design to avoid the capillarity effect. That's one thing, because we can engineer the properties of our fluid. We are able to improve its behavior with capillarity. We're not there yet, and so in the meantime, the way that we solve it is obviously working with the right cable suppliers. There are cables out there that are designed specifically for this application and that completely remove the burden of capillarity.
Okay, let's talk about the fiber for a second then as well.
Same approach. I mean, the fiber optics, it's just a specific material that's on the outside of the cable, and that's something that we've also
I believe here we're talking about, or the question being asked has to do with the issues of using fiber optic submerged.
Yeah. So in that specific case, we've been working a lot with the refraction index of the fluid to allow us to operate submerged fiber optics. We are working with some of the major networking companies out there, and all the ones you can think of where our R&D teams are working together. One of the challenges that we have, and very openly, if the transceivers are not enclosed, encapsulated, and so the fluid goes into the transceivers, there's a challenge there that we're looking at overcoming, and there are multiple ways of tackling that. The industry has gone down the route of transceivers that are not sealed, and so that's a challenge. We have transceivers that are sealed, that are available from multiple suppliers and can be deployed in immersion cooling for 100G, 400G networks. It's just that we want to make sure also that the standard that's mostly used out there can also be used in immersion cooling, and that's where our R&Ds are working with the networking OEMs.
Yeah, I think it's fair to say, like from our side, we see this in a very holistic way. We're not only working together with the server manufacturers, we're also working very closely with the switch manufacturers, the component manufacturers, in order to ensure that we really can deliver this end to end. Because there's no point in having fantastic computer if your interconnect is just not working.
Absolutely.
So yeah, just to let you know, we are looking at it in a holistic way. Thanks for that again, Koen. A question here regarding what about fire protected systems? Example, HIFOG?
Yeah. So
water mist system, water to the oil.
Yeah. So specifically, our fluid has a property of allowing substantial amounts of water to be mixed with it before it's conductive. The design of the smart pod has a specific shape that allows, for example, mist water systems or even traditional sprinkler systems to be activated, and the water that would never reach the coolant or the compute. So with immersion, we can use a much wider range of and more aggressive fire suppression systems because of the properties of the liquid, because the liquid is protecting the IT equipment, and so the main part of the investment is completely protected, and because of the design of this tank, which essentially you could have a sprinkler on top of it and it would not affect the operation of the system.
Okay. Interesting to address the reliability of the equipment as a good argument for the physics of reliabilities around the thermal shocking of the microelectronics. Absolutely. In other words, electric components like to be kept at the same temperature and don't like fast temperature changes. And obviously with immersion, you have a certain amount of inertia. So even changing from one temperature to another, it doesn't happen suddenly like it does in air. It actually happens gradually over time if you want it. And with our solution as well, we can keep your components within a very, very small range in order to keep them very happy and give them a longer life and be more reliable. There's always comments about what you can and what you cannot put into immersion. Example, leaching of plasticizers from cables, or what about spinning disks? Can helium-sealed disks be used, or is it always SSD?
So it's SSD, it's NVMe, and it's helium-sealed. Essentially, these are the three types of storage that can be storage media that can be used. Of course, traditional spinning disks that are not sealed cannot be used.
And what about these plasticizers that were mentioned from cables?
Yeah, so this is obviously one of the challenges that we're working with the OEMs. A lot of the lower end
RJ45 cables, really.
RJ45, but also some of the cables that are actually in the server,
yeah,
in the servers themselves. They pose a challenge because, let's say the biggest challenge is just a visual challenge, because the cable itself will not degrade, but it will transfer certain color into the fluids. And those are things that don't degrade the dielectric properties of the fluid itself, but obviously they're staining the fluid in some way. It's something that we need to avoid. So
we have recommendations on types of cabling, etc., to be used as
yes,
well.
we have recommendations. We have recommendations from OEMs that have designed servers specific for immersion cooling, and so none of this is an issue. So yeah.
Okay, for all of you out there, just giving you a last chance to put in any other questions. What I did want to say was, where we look at just here the next events. I think I've already mentioned them. You're all probably very much aware of them, apart from one very important one, which is the Smart City Expo in World Congress in Barcelona from the 19th to the 21st. Anyway, just again, DCD London, the 5th and 6th of November. You can meet Daniel there. You can meet Gloria, our marketing director there, along with some partners who will also be at the booth. The Fujitsu Forum in Munich, I'll be there along with Barney from our sales team. Then there's the Evocative Open House in San Jose, where we'll also possibly be represented by a special guest. We have to see about that one. We'll keep that one a little mystery for the moment. But apart from that, also ably looked after by Jeff Brown, our managing director from North America. And also Matteo with the drum roll, if you could go to the last slide here, please, or what I think is the last slide. So everybody, SC19, and I presume most of you are going to be there. And if you don't stop by our booth and don't spend time with us, I'm going to hunt you down. So you can see where we are. We're very close to the entrance on Welton Street. We are not far away from the NASA booth. So that also gives you a little bit of an indication. If you see NASA, you're right beside Submer, so go there. That's fantastic. And as I said as well, one of the things we'll be showcasing is our cooperation with multiple hardware vendors, server vendors, switch vendors as well, where you can see for yourself all of these people we've been working with over the last months and years in order to make sure that they are comfortable with immersion cooling, so that you're comfortable with immersion cooling as well.
I think we'll also be joined by one of our installation and maintenance partners, CompuDynamics, at our booth, which will also give you an insight as to what it represents to deploy, maintain, and operate these systems in the long run. I'm sure you'll be able to meet Lee Piazza there.
Yeah, Lee and maybe Steve himself will come out there. It was great seeing you guys last week. But the point is to, again, show we have this partnership, we have these partnerships in North America, and especially the partnership with CompuDynamics for installation, for maintenance, and really showing people the power we're bringing together then to the North American market. Again, Matteo, who is sitting over here, for anyone who can't see him, he's always hiding in the corner. You can say a quick hello, Matteo. There we go. We can't let him say too much because he's got to do the work sometimes. So we have to just ask you, please do subscribe to our YouTube channel. Keep in touch with us via social media. Any other questions you have, please feel free to send them. Daniel@submer.com, d@submer.com, Matteo@submer.com. Basically, if you can spell the name and you can write submer.com, you've found us. Thank you all so much for tuning in, and for everyone listening to this afterwards. Hope you've enjoyed, and looking forward to meeting you all in person somewhere around the world very soon. And apart from that, we'll be back to you next month with another installment. Thank you.
Thank you.